Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of congruence and transformations. This is standard 8.10b in the great state of Texas, and we are using item number 8 of the 2022 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a rectangle graphed on a coordinate grid, and which transformation will result in a rectangle that is not congruent. All right, so in order to do this, I'm just going to need to visualize this a little bit. So I'm going to draw a coordinate grid, and I'm just going to draw the same rectangle each time. So I'm going to make, kind of a short and long here rectangle. There we go. All right, so there's my rectangle. So if I want to do a dilation by a scale factor of 3, so that means, right, we're going to take our x and y coordinates, and we're going to multiply them by 3. So each of my x's gets times 3, each of my y's gets times 3, so it's going to get a little bit higher, a little bit over to the right, but wow, it's going to get 3 times as long. So that's probably going to end up going off the screen here. There we go. So that's what a dilation would look like. And that is definitely not congruent because I'm making it 3 times as big here. Scale factor 3. So I'm thinking this could be my answer because that's definitely not congruent. But let's check G here. All right, so see if I can kind of draw that same rectangle here. All right, so I'm going to do a rotation of 180 degrees counterclockwise. So counterclockwise goes this way. 180 degrees means it's going to go halfway around a circle, right? So that means it's probably going to end up kind of looking like this. But other than that, now I didn't necessarily draw it correctly because it's probably not that long here. See if I can get rid of that. I didn't change the shape. I didn't change the size. A rotation doesn't do any of that. A dilation does. So it's still congruent. I just rotated around like a clock. So let's check H. See if that's going to change the size. That's really what we're looking for. If it's congruent, it's the same size, same shape. So not congruent means we're looking to change the size. Translation, 90 units to the right. Wow. I already started it kind of hanging off the grid here. So if I were to go 90 units to the right, I'm literally going to take this thing and I'm just going to move it, and it's probably going to end up way over here. That's not even 90 units, probably farther than that. I'm just sliding it. Okay, so this is a slide. This is sometimes called a turn. But when I'm sliding it, I'm not making it any larger. I'm not making it any smaller. I'm just taking my shape and I'm sliding it in a certain direction. In this case, 90 units to the right, which means it's still congruent because it's still the same size and still the same shape. I'm just sliding it. Let's check J. All right, so here's my J. Try to get my same rectangle or something close. All right, so I'm going to reflect it across the x-axis. So here's my x-axis. And so what we do is we kind of flip it. It's like a mirror. The mirror happens to be, in this case, the x-axis. Sometimes it's the y-axis. So this is a flip. But if I flip it, I'm not making it any larger. I'm not making it any smaller. I'm taking the exact same shape, and I'm flipping it across a certain axis, which means it is still congruent. And if it's still congruent, it is not the answer I'm looking for. So we've got rotations, we've got translations, we've got reflections. All of them keep congruence. If you want to break congruence, make something that's either larger or smaller, still similar, but larger or smaller, you need to find a dilation F.